You will have an entire section that is just proof work. It will include some proofs like this, where you have the statements and you have to put in reasons. And what we're going to take a look at afterwards called the coordinate proof. That will all be in one section. So maybe you'll have 5 problems, and you'll get 20 points for each problem. You can get partial credit on this. You can get partial credit by just doing this. And putting it into the drawing. How do you show that angle ABC is congruent to angle DEC in the drawing? What's the middle letter? What's the middle letter? Show that the two angles are congruent. How do I show that CB is congruent to CE? How do I show segments congruent? CB, CE. You would get half credit for that. You get 10 points out of 20 just for doing that. Just making sure that you have the givens in your proof and in the diagram itself. Now we're going to start adding things. This is exactly what you've been doing, only we're putting it in a table form. It's no different. If you were just looking at this drawing and ignoring all of this behind me, what would you add to the drawing? Vertical angles. What does THM stand for? Theorem. You're just putting it down line by line as you're thinking. But make sure that you're actually looking at vertical angles. What's the middle letter here? C, C. So we're talking about the two angles right in the center. That looks correct. What's the little symbol in front of ABC and DEC in the last line? Triangles. If you are proving that triangles are congruent, you've only got the 5 choices that are on the side board. You know it's got to be one of those 5. Look at your drawing. Focus on one triangle. What components do you have? What are these things? Angle, side, angle. Is the side directly in between the angles? Then we're allowed to say ASA. Done. 20 points out of 20 points. True. Make sure that this statement is the last statement. That's what we're trying to do. We're trying to prove that the triangles are congruent, so that better be the last line. Start off the next proof the same way. You get half credit just for positioning the given statements in the table and in the diagram. So circle this stuff. You know it's got to show up down here someplace. You know you got to put it over here. I want a given here. Be careful, it might not be the first 2 statements. They might position the given statements in various places. Usually it's at the beginning. In this case it is. How do I show that FG is congruent to HJ in the drawing? Dashes. Make sure you're actually showing the right symbols on the right components in the figure. FG, HJ. What does this symbol mean?
Parallel.
Parallel. Let's write that down just in case. Sometimes you will see that perfectly vertical. Sometimes it'll be slanted a little bit. If you see 2 lines that look parallel in between 2 segments, it means parallel. How do I show that in the drawing?
Right arrow.
Let's put a couple arrows. Arrows mean something different than congruent. Don't get the two confused. You'd get half credit just for doing that. What is this telling me?
That means that's
How do I show that in here?
dash.
I can put a slash mark on that. What is our technical name for saying that something is equal to itself and is in both triangles? Reflexive what? Property. So the common side is our way of thinking about it, but our technical way of thinking about it is reflexive property. All right, we're getting closer. Go to the next line. We're dealing with angles. So what I do is I actually trace the three letters. F, G, J. F to G to J. So I'm focused on that angle right there. Next one is H, J, G. I'll put that in purple. H to J, back to G. So now I'm looking at this one here. Why is that the same as that? Z shape, but you don't want to write down, it's the Z shape. Alternate, interior, angles. We're going to be more specific now with our reasons. That's a theorem. Just like vertical angles is a theorem. You can't do that unless someplace previous we are saying that something is parallel. They've got to be parallel in order for the alternate interior angles to be equal. And we've got that. What symbols are showing up in the next line? Triangles. What should you be thinking of? You got your 5 choices. What am I looking at in this drawing? If I'm focused just on, let's see if I can do this green. Side, angle, side. But I can only do that if the angle is formed by the two sides I'm talking about. Is the angle formed by this side and this side?
Yes.
S, A, S. That's great. This is the chapter on proving triangles congruent, so you're probably going to be proving triangles congruent. But is that what we're trying to prove ultimately? No, ultimately we're trying to prove that FJ is congruent to HG. I'm going to put that in my special purple pen right here. That's what I'm trying to prove, that those two, is that right?
Yeah.
FJ, FJ, HG. What did I prove on this line? I proved that what two things were congruent? To what? Two triangles. If the entire triangle is the same, does it make sense that the pieces of the triangle have to be the same?
Yeah.
Instead of writing out, because the big triangles are the same, then all the little pieces that are corresponding are the same in this little line, we write C, P, C, T, C. Or I can write definition of congruent triangles. Let me move this up a little bit. I've seen both show up on SOL tests. I've seen both in all sorts of different textbooks. CPCTC is kind of a classic abbreviation that's used, and it's a good idea to know what it actually means. Instead of saying, since the big triangles are the same, then all the little pieces have to be the same, we say CPCTC. These two are the CP part. Why am I saying FJ goes with HG? Why don't I write FJ congruent to FG? Why am I choosing these two instead of FJ with something else? What's the word I'm looking for? What do they do?
Correspond.
Yes. From the back of the room. Corresponding parts. So you gotta have parts that actually correspond with each other. But you can't say CPCTC unless you have something on the line right before it. What's on the line right before it? What are these things? That's the next one. Congruent triangles. And the last C refers to that symbol. Congruent. We're leaving out a few little words. Corresponding parts of congruent triangles are congruent. Instead of saying a big long sentence about how the whole thing is the same, so all the little pieces are the same, we say CPCTC. Or a lot of people just like to say definition of congruent triangles because that's what's on the line before. So even though you don't know all the time where these proofs are headed, you are in Chapter 4. Chapter 4 is about proving triangles congruent. So just do that on every single proof that you see on this test. Prove that the triangles are congruent. Sometimes you're done. Other times you got to take it a few steps further. In this case, just one step. We call that CPCTC, or definition of congruent triangles. Turn your paper over. Try the back side of this on your own. All right. Dustin is telling me to do this. He says if he was just doing a problem and not a proof, he would put that in. How many people did that? You've got to actually write it out, and you can't just say angle Z is congruent to angle Z, because what's angle Z? Is it this one, this one, this one, or this one? So you got to name it with 3 letters. So he said X, Z, Y. You want the Z in the middle. It's the vertex. And what corresponds to X? W. So I'll have W, Z, V. What would be your justification? Vertical angles THM. He's jumping right to, is that what we're trying to prove? No. So we know we'll have another step at some point. But this is the congruency chapter, so we know that we'll be proving triangles congruent. What are you looking at, Dustin? Which choice? SAS. At that point, you've proven that the 2 triangles are identical, based on only 3 pieces of information. What I've been telling my other classes is that they're losing points because they're not writing everything down. If you wrote down SAS, how many pieces are there? 3. So you should have 3 congruency statements preceding it, someplace. Congruent, congruent, congruent. So you know that there's 3 pieces up here that match up with these 3 SAS components. If you go back and you notice I only have 2 things, then maybe you forgot something. You should have a statement up there. That's great. This is wonderful. You'd get 15 points out of 20. You've got to actually prove whatever the proof statement is and make sure that it shows up down here someplace. Right at the bottom. So Y and V. What allows me to now say that this angle is the same as that angle? CPCTC. Since we said the triangles are the same, every single corresponding part must be the same. Does Y correspond to V? Yes, it does. That's the CT part. Do we have congruent triangles on the line before?
Yes.
That's the CT part. And then the last part is what we're actually saying, that they're congruent. We don't know a whole lot right now. That's about it as far as the proofs go. They're going to be 5 lines long, maybe 6 lines long. You know this is the congruency chapter. You're going to be proving triangles congruent no matter what. Sometimes that's the end, sometimes you go a little bit further.